In 1911, a car called the Marmon Wasp won the very first Indianapolis 500. It introduced the rear-view mirror to motorsport. 20 years later, the company that built it couldn't sell a single car, so they started making trucks instead, then tanks, then trolley buses, then they stopped making all of those too. And somehow, they're still in business. The Marmon name reaches back further than most people expect, all the way to 1851, when a company called Nordyke and Marmon set up shop in Indianapolis making flour mill machinery. For nearly half a century, that was the whole operation. Grinding flour. Building the machines that grind flour. Refining the machines that grind flour. Not exactly the raw material of automotive legend. But the Marmon family had engineering wired into their DNA, and around the turn of the 20th century, a young man named Howard Carpenter Marmon decided that wheat wasn't enough anymore. He was 23 years old and he wanted to build cars. His first automobile, completed in 1902, was remarkably sophisticated for its era. Overhead valves, air-cooled engine. Within a few years, Howard was experimenting with V4 and V8 engine configurations, pushing into territory most automakers wouldn't approach for another decade or more. The cars earned a reputation fast, quick, beautifully put together, mechanically advanced in ways that surprised even experienced engineers, the kind of automobiles that wealthy Americans genuinely wanted to own. And then came the race that changed everything for the brand. May 30th, 1911. 40 cars lined up at the brand-new Indianapolis Motor Speedway for the inaugural 500-mile race. 80,000 spectators filled the grandstands, most having only the vaguest idea what they were about to see. Among the drivers was a man named Ray Harrington, an engineer who also raced cars. He sat alone in his yellow number 32 Marmon Wasp. That was already unusual. Every other car on the grid carried two people, a driver and a riding mechanic whose primary job was to physically turn around and watch for traffic approaching from behind. Harrington's rivals protested. During practice, they told officials he was a safety hazard. Without a spotter, he couldn't see what was coming up behind him. Harrington's answer was elegant and practical. He mounted a small mirror above the cowling. First rear-view mirror on a race car. Possibly the first rear-view mirror on any automobile, period. There's debate about earlier examples on horse carriages, but Harrington made it famous. His second innovation was simpler. While the rest of the field drove flat out and destroyed their tires, Harrington chose a steady, conservative pace. No heroics, no risks, just smooth, efficient laps. The result was devastating for the competition. Harrington had 0 tire blowouts the entire race. He made 4 pit stops total. The second-place finisher, Ralph Mulford, went through 14 tire changes. Harrington crossed the line first after 6 hours and 42 minutes at an average speed of about 75 miles per hour, collecting a purse of $14,250. After the race, he told the press something remarkable for a winning driver. He said the Marmon won that race, not him. He was just the man holding the wheel. That victory cemented Marmon's reputation nationally. For the next 2 decades, the company produced some of the finest luxury cars in the United States, competing directly with Packard, Cadillac, Pierce Arrow, and Duesenberg. Howard Marmon was a restless innovator who pioneered the use of aluminum throughout his vehicles, employing it in radiators, transmissions, rear axles, fenders, and body panels years before competitors considered the material viable. His 1916 Model 34 was one of the most technically progressive automobiles of its era. In 1928, Marmon's peak year, the factory turned out just under 15,000 cars. That sounds healthy until you compare it to General Motors, which produced roughly 1.5 million vehicles that same year. Marmon was a boutique shop in a rapidly industrializing business, small, brilliant, and perpetually outgunned on scale. That didn't stop Howard from chasing his biggest dream, a 16-cylinder engine. He started the project in the late 1920s, initially joining two of his straight 8 blocks together. That approach didn't work. So he threw it out, started from zero, and designed something entirely new. What emerged was one of the great American engines. The Marmon-16 debuted in 1931, 491 cubic inches of displacement from an 8-liter V16, arranged at a 45-degree bank angle for near-perfect mechanical balance. 200 horsepower at 3,400 revolutions per minute. All aluminum construction with steel cylinder liners. A single camshaft in the block, driving overhead valves through push rods and rocker arms, the valve gear engineered so precisely it was nearly inaudible at idle. The engine weighed 930 pounds. For comparison, Cadillac's competing V16 displaced only 452 cubic inches, made 165 horsepower, and weighed considerably more. The complete Marmon-16 sat on a 145-inch wheelbase chassis, tipped the scales at about 5,100 pounds, and cruised past 100 miles per hour without strain. Torque, never officially published, was reliably estimated between 380 and 400 pound-feet. The power-to-weight ratio was the best of any luxury automobile in America. Only the Duesenberg Model J surpassed it, and the Marmon could reportedly out-accelerate a Duesenberg from a standing start, despite costing about 1/3 as much. A San Francisco newspaper reporter, after driving the 16 up the city's hills, wrote that he had never piloted a luxury car with that kind of climbing ability. The body was styled by Walter Dorwin Teague, Jr., who was 18 years old and a freshman at MIT at the time. His father, the celebrated industrial designer Walter Dorwin Teague, Sr., got the public credit. The elder Teague had never designed an automobile before. He didn't even know how to drive. But the design was clean, sleek, and more forward-looking than most luxury cars of the early 30s. The timing, however, was a catastrophe. Cadillac had beaten Marmon to market with its own V16 by more than a year, stealing the excitement that should have belonged to Indianapolis. Worse, both of Cadillac's key V16 engineers, Owen Nacker and James Bohannon, had previously worked at Marmon. The company had effectively trained the people who scooped them, and by 1931, the Great Depression had eviscerated the market for luxury automobiles. A $5,000 car was a fantasy for a country where millions couldn't feed their families. Between 1931 and May of 1933, Marmon sold approximately 390 16s. Then the company filed for bankruptcy. About 76 are known to survive today. Only 8 of those are convertible coupes. If you ever stand next to one, you're looking at a machine that almost nobody alive experienced when it was new. Howard Marmon needed to pivot, fast. Salvation arrived in the person of a man who went by a military rank he never officially earned. Arthur William Sidney Harrington was born in Coddenham, Suffolk, England, on March 30th, 1891. His family emigrated to America when he was 5, settling in Madison, New Jersey. He studied at Stevens Preparatory School and then Stevens Institute of Technology in Hoboken. His first job out of school was at Harley-Davidson in Milwaukee. When the United States entered World War I, Harrington went to France as a motorcycle dispatch rider with the American Expeditionary Forces, serving initially as a lieutenant and eventually reaching the rank of captain. After the war, he stayed on as a consultant, and colleagues in the Motor Transport Division began calling him Colonel. He never held that rank, but the title stuck, and he used it for the rest of his life. What shaped his entire career was the mud. In France, Harrington watched conventional vehicles fail. Trucks sank into churned-up roads. Supply wagons bogged down in fields that turned to soup after rain. Entire logistics chains collapsed not because of enemy action, but because two-wheel drive vehicles simply could not go where they needed to go. Soldiers died waiting for supplies that were stuck in a ditch 3 miles behind the lines. The problem wasn't strategy, it was traction, and Harrington decided he was going to fix it. After years of Army consulting, he observed in late 1925 that a truck built by a small outfit called Coleman Motors outperformed every military vehicle in off-road trials. He left the Army, joined Coleman as general manager of their D.C. branch, and spent 6 years there designing all-wheel drive systems. During this period, he developed and patented a vibration-free universal joint that solved one of the fundamental engineering problems of all-wheel drive. In most systems of the era, transmitting power to the front axle while allowing the wheels to steer caused violent vibrations that tore components apart at speed. Harrington's joint eliminated that vibration. It made practical, reliable, full-time all-wheel drive achievable in heavy vehicles. That patent would underpin everything his company built for the next 90 years. On March 13, 1931, Harrington partnered with Walter Carpenter Marmon and Howard Marmon to incorporate the Marmon-Herrington Company in Indianapolis. The luxury car market was finished. All-wheel drive trucks were the bet. The gamble paid off immediately. Their first contract was for 33 T-1 4x4 aircraft refueling trucks for the U.S. military, powered by 6-cylinder Hercules engines. Orders followed rapidly, 4x4 and 6x6 vehicles for the American and Persian armies. General load carriers, weapons towers, mobile machine shops, and wreckers. Some featured four-wheel steering as well as four-wheel drive. In 1932, the company built the largest trucks in the world at that time, massive all-wheel drive truck and trailer combinations for the Iraqi Pipeline Company, designed to haul heavy pipe across open desert. No other manufacturer could do this. Marmon-Herrington could because Harrington's drivetrain technology made it possible. Then came the business move that showed real strategic thinking. Building entire trucks from scratch was slow and expensive, but converting existing trucks to all-wheel drive? That was cheaper, faster, and scalable. In 1935, Marmon-Herrington began converting Ford 1.5-ton V8 trucks to all-wheel drive using their patented components. Ford agreed to sell the converted vehicles through their own dealer network, priced at roughly double the cost of standard models. For Marmon-Herrington, it was the best of both worlds. Ford's vast sales infrastructure combined with Marmon-Herrington's technical superiority. The conversions were almost entirely hand-built, so production was slow and volumes were modest. Fewer than 15 Ford conversion examples are believed to survive today. But the margins were healthy, and the partnership established the model that would define the company for the rest of its existence. Don't build the whole truck. Build the part that makes it go where other trucks can't. By 1936, the partnership produced the T9 half-track, an unarmored vehicle with rear tracks, a powered front axle, and a front ditch roller. Crude-looking but enormously effective, the technology from that vehicle reappeared directly in the armored half-tracks of World War II. If you're enjoying this, hit subscribe. We cover stuff like this every week. All right, back to it. When the war arrived, Marmon-Herrington's expertise was suddenly needed everywhere. Their most extraordinary contribution came through a collaboration with South Africa that sounds like something from a logistics textbook written by someone who'd lost their mind. In 1938, the South African government needed armored cars for the Union Defense Force. The country had essentially no automotive manufacturing capability, so the vehicle would have to be assembled locally from imported components. Marmon-Herrington won the contract with a design submitted in 1939. The supply chain was staggering. Four-wheel drive train and transmission from Marmon-Herrington in Indianapolis, chassis and engine from Ford in Canada, armament from Britain, armor plates from the South African Iron and Steel Industrial Corporation. The armored hull was assembled by the Dorman-Long Structural Steel Company. Final assembly, fitting, and delivery by Ford Motor Company of South Africa. components sourced from 4 countries, shipped to a 5th, to build armored vehicles that would fight in a 6th, all while German U-boats were hunting the supply convoys. The vehicles, officially designated South African reconnaissance cars, became universally known as Marmon-Herringtons, partly because the only visible manufacturer's badge on the exterior was the Marmon-Herrington emblem stamped into each wheel hub of the front axle. The Mark I was basic, about 130 built, 2-wheel drive on the early batch, thin riveted armor, a Ford V8 engine, open-top turret with Vickers machine guns, useful against Italian colonial forces in East Africa, but quickly obsolete. The Mark II introduced true all-wheel drive, the first in Commonwealth Armored Car Service. It held its own against the Italians, but was dangerously outmatched when the German Africa Corps brought heavier guns and better armor to the North African theater. The Mark III shortened the wheelbase for improved desert agility, increased frontal armor to 12 millimeters, and mounted a more powerful 95 horsepower Ford engine, giving a road speed of about 50 miles per hour. More than 2,500 were produced. Crews from half a dozen nations drove them across East Africa and the Western Desert. In the field, soldiers got creative. When the Standard Boys anti-tank rifle proved useless against German armor, they ripped it out and mounted captured German 20mm flak guns or Italian Breda autocannons instead. Nobody waited for procurement approval. They needed firepower, and they improvised. The Mark IV arrived in '43 as a complete redesign, rear-mounted engine, welded monocoque hull, a proper 2-man turret with a 2-pounder anti-tank gun and coaxial Browning machine gun, over 2,000, built in 2 variants. By then, the Desert War was won, and armored cars were less useful in the Italian mountains. But these vehicles refused to die. They served post-war with the armies of Jordan, Israel, Greece, Belgium, and Cyprus. The Greek army operated them in the Aegean Islands into the 1990s. The Cypriot National Guard used them during the Turkish invasion in 1974. Vehicles designed during World War II, still in active military service 50 years later. In total, 5,746 Marmon-Herrington armored cars were produced during the war. Simultaneously, Indianapolis was trying to build a flying tank. The British War Office wanted a purpose-built airborne light tank that could fit inside a Hamilcar glider and support paratroopers on the ground. In May 1941, the U.S. Ordnance Department chose Marmon-Herrington's design over proposals from General Motors and the famous J. Walter Christie, whose submissions failed to meet size requirements. Twice. The specifications were demanding: maximum weight under 8 tons, 37mm main gun, 3-man crew, top road speed of 40 miles per hour, operational range of 200 miles, armor of 25 to 50 millimeters. The prototype, designated the Light Tank T9, ran on a Lycoming 6-cylinder air-cooled engine producing 165 horsepower. It used a vertical volute spring suspension system and was designed to either hang beneath a Douglas C-54 Skymaster cargo plane with its turret removed or, more practically, fit inside a British Hamilcar glider, fully assembled. The problem started immediately. The suspension was too fragile for the vehicle's weight. Road wheels fell out of alignment during testing. The transmission was unreliable. The original order for 1,900 tanks was cut to 960. The Armored Board's preliminary report declared the vehicle unsatisfactory, singling out durability and the powertrain for particular criticism. Production finally began in April of '43, over a year behind schedule, and by the time Marmon-Herrington got the assembly line running at any meaningful pace, the design was already obsolete. 830 were built before production ended in February of '44. The U.S. Army designated it M22 and refused to issue it to a single combat unit. The British, however, took 260 under Lend-Lease and named them the Locust. They got exactly one combat opportunity, Operation Varsity, March 24, 1945, the Rhine crossing. 8 Locusts were loaded into Hamilcar gliders and launched into battle. Several were destroyed on landing or in the first minutes afterward. Only 2 reached their planned objective, a piece of high ground they held alongside an infantry company. But the thin-skinned tanks attracted so much German artillery fire that the infantry around them began taking devastating casualties. They were forced to withdraw. The Locust was classified obsolete in '46. To be fair, everyone knew it was obsolete 3 years earlier. The paperwork just needed time to catch up. At wartime peak, the Indianapolis factory employed 1,500 workers building trucks, armored vehicle components, the Locust tank, airport fire trucks, and all-wheel drive conversion kits. Business was strong. Then the shooting stopped, and the military contracts evaporated almost overnight. Marmon-Herrington needed a new product line, and they needed it immediately. The answer was trolley buses. Electric buses powered by overhead wires. It sounds like an odd pivot for a company that built desert war machines, but the engineering overlap was real. They understood chassis design, vehicle assembly, commercial fleet markets, and the art of building something that lasted. In '45, they constructed a brand new state-of-the-art factory in Indianapolis specifically for trolleybus production. The technical execution was superb. Marmon-Herrington trolley coaches featured lightweight monocoque body construction, eliminating the traditional heavy steel frame. Double girder sidewalls provided structural rigidity without adding weight. General Electric motors and controllers handled the electrical propulsion, running on 600 to 800 volt DC power from overhead wires. The buses came in models designated by seating capacity: the TC40, TC44, TC46, TC48, and TC49. The TC44 and TC46 were 36 feet long. The TC48 and TC49 stretched to 39 feet. Every vehicle was built at Indianapolis. The combination of durability, lightweight construction, and competitive pricing made Marmon-Herrington trolley buses the dominant product in post-war transit. Chicago Transit Authority placed a single order for 349 units delivered in '51 and '52, the largest single order the company ever received. San Francisco Municipal Railway bought 260. Cincinnati Street Railway took 214. Cleveland Railway ordered 125. In total, Marmon-Herrington supplied trolley buses to 16 American cities and 2 cities in Brazil. Between '46 and '59, 1,624 trolley buses came out of the Indianapolis plant. The longevity of these vehicles was remarkable. San Francisco ran its Marmon-Herrington coaches for 25 years before retiring the last ones in '76. Chicago's fleet operated until '73. Philadelphia kept theirs running until '81. Retired American units were sold secondhand to Mexico City's Transit Authority, where some ran in original form until '88. The Mexican company Moyata rebuilt the bodies in the '80s, and the last 5 rebuilt Marmon-Herrington trolley buses in Mexico City survived until 2002. More than half a century of daily transit service from a design born in the late 1940s. If you ever hear someone say they don't build them like they used to, this is what they're talking about. But by the late '50s, the trolley bus market in North America was finished. Cities were tearing down overhead wires and replacing electric fleets with diesel buses. The economics had shifted, the political winds favored highways and petroleum, and Marmon-Herrington's trolley bus era ended in '59. The company also attempted transit motor buses, multi-stop delivery vans marketed as the Deliver-All, and in '61 a contract to re-engine roughly 1,000 Greyhound coaches. None generated enough revenue to sustain a company built around full vehicle manufacturing. The fundamental issue was never quality. Marmon-Herrington products were almost universally well-engineered and durable. The problem was scale. They were a small, specialized manufacturer competing in industries that increasingly rewarded massive production volumes, nationwide dealer networks, and the ability to undercut on price. The math didn't work. In the early 1960s, the Pritzker family of Chicago acquired the company. The Pritzkers were investors, not truck enthusiasts. They examined the books, identified what was profitable and what wasn't, and made a clear-eyed decision. Full vehicle manufacturing was over. The truck designs were sold to a new entity called the Marmon Motor Company, which set up operations in Denton, Texas. That company began building low-volume, handmade Class 8 highway tractors for owner-operators. Estimated production was about 300 units per year. Each truck was custom specified by the buyer. The quality was extraordinary. Drivers called them the Rolls-Royce of American trucking. One former owner, a collector named Chris Buck, later said each Marmon was built exactly the way the customer wanted it, and that kind of personalization simply doesn't exist anymore. But the larger truck manufacturers eventually closed the luxury gap. Better cabs, quieter rides, more comfortable sleepers. Marmon's hand-built advantage shrank year by year, and the economics of 300 trucks annually couldn't compete with companies producing tens of thousands. The last Marmon truck rolled off the line in Garland, Texas in 1997. The factory was leased to Navistar for Paystar Vocational Truck Production. Marmon-Herrington's main plant and headquarters in Indianapolis closed in 1963. The remaining operations folded into an association of companies that became the Marmon Group in '64. During the Cold War, the company diversified into aircraft, missile, and rocket ground support equipment through a subsidiary called Cardair in Chicago. But the core business, the one Arthur Harrington envisioned in the mud of France, never stopped. All-wheel drive conversions, transfer cases, front-drive axles, drivetrain components for vehicles that needed to go where roads didn't exist. Arthur Harrington himself died on September 6, 1970, at age 79. He was killed in an automobile accident in Indianapolis while driving a small foreign sports car. The man who spent his entire career making vehicles more capable off-road was undone on a city street. He's buried at Crown Hill Cemetery in Indianapolis, alongside other automotive pioneers from the city's golden age. In 2008, Berkshire Hathaway purchased a majority stake in Marmon Holdings, which includes both the Marmon Group and Marmon-Herrington. Warren Buffett's company now owns the descendant of a business that started grinding flour in 1851. From wheat to race cars, to luxury automobiles, to military trucks, to desert armor, to trolley buses, to axle components. Marmon-Herrington is based in Louisville, Kentucky today. The company converts commercial trucks from Ford, Freightliner, International, and Kenworth to all-wheel drive. It manufactures front drive axles, transfer cases, planetary drive axles, and custom driveline systems for severe-duty applications, snowplows, fire and rescue trucks, military tactical vehicles, construction equipment, municipal utility trucks. If a vehicle needs to operate in conditions where standard two-wheel drive means getting stuck, there's a strong chance Marmon-Herrington hardware is making that possible. Their axles and transfer cases appear on some of the newest military vehicles rolling off assembly lines today, just as their components appeared on converted Ford pickups in 1935. The company that won the first Indy 500 built a 16-cylinder engine that embarrassed Cadillac and could out-accelerate a Duesenberg, armed the deserts of North Africa with nearly 6,000 armored cars, tried to build a tank that could fly inside a glider, electrified the streets of Chicago and San Francisco, and then quietly became the world's most enduring manufacturer of drivetrain components almost nobody has heard of. They didn't stop making trucks because they failed at it. They stopped because they discovered that the most durable business wasn't the one with your name on the hood. It was the one that made every other truck on the road better at its job. There's something worth sitting with in that. Not every great company needs to be famous. Not every legacy needs a logo visible from the highway. Sometimes the real contribution is underneath, in the axle, in the transfer case, in the universal joint that a man patented after watching trucks sink in French mud a century ago. Marmon-Herrington figured that out. It took them 30 years of reinvention, several near-death experiences, and one of the most improbable corporate journeys in American industrial history. But they figured it out, and there you have it. From flour mills to race cars to desert armor to trolley buses to transfer cases. If you've ridden in a vehicle with Marmon-Herrington components and never knew it, well, now you do. Let me know in the comments if I got something wrong. Probably did. That's what comments are for. Subscribe if you want more of these deep dives. We do this every week.